Hello friends, welcome back to my channel. Today's video we will learn about linear, how we can measure the length with linear in Siemens PLC S7-200. But before start this video, please like, share and subscribe this channel. This way you will be never miss upcoming videos. So let's start. I will open my Microwin software and here we will first choose first I will show you my camera. This is my PLC which is connected, which I'm using this analog inputs. That yellow wire is output of the linear, and this brown wire is the plus voltage, and this ground wire is this green color. This wire is for minus voltage. So what I do, how I make this hardware, I will explain you little more. This ground wire is, you can understand, this is ground wire just, and this is brown wire. I put the voltage to my linear from the PLC 6 volts lump sum, and that's the I take output from the this yellow wire to my linear. I show you my linear little, make it down. I will camera. This is my linear which I'm using in this with this PLC. That's, if I try to show you, you can see this is the resistive linear potentiometer. That the wiring also you can see. One number is the 0 plus volt. One number is plus voltage and two number is output, and third number is ground voltage. So we will configure this linear in our program, and I will show you how we can measure the length in with the PLC. So first of all, we will take one input. Sorry, not look like same. We have to just click here, and here we will take one internal always on SM 0.0, and here we will configure analog output, because we have to be give the value for our linear voltage. So we will take one data block and we will move command use. Where is this move? Yeah, this is move commands. This move W we will choose, and what's the number of data registers I will explain you. In Siemens S7-200 PLC, that the analog output data register is have a AQW0. So we put any data register here, for example VW0, we put input, and we will take the output voltage at the AQW0 and click enter. And in next row, same as we will make this network, control C, and you can make it here control V, and this is also you can make it control C, and here make it control V. So this numbering we will change, and this is we will define for analog output value data register, and this we will define for analog input value. So this data register we will do analog input AIW0. This is the number of analog input address, because of when you like to read the value in analog in Siemens PLC S7-200, that have to be used AIW0, and take it any data register. For example, MW10 data register I will choose to read the value at the MW10. So let's first we will configure this our program and write to PLC. Wait for seconds. Download. The program is successfully downloading to the PLC and click OK. And just go to the status, and now as per seen, here is some value showing at the input, but here is we didn't give any value. We have give, for example, right 16,000. If I give, that will be coming around 4 volts or 5 volts look like. And if we write it here, for example, you can see here is also increase the value at, because of our linear is already connected with our PLC. So if I put this one 20,000, after this value will be changed. You can see this is now 20,176 value coming at our analog input. So how we can use this value? I show you in linear. You can see, will show you in linear, as we will move this linear. This I will make it small little, because you will be physically see 100%. Now as I move my linear, you can see this value will be also moves. Slowly we will move, and you can see this value thus goes to reduce. Right, this is our analog value. So when I reverse back, after this value will be increased. So for an example, this is now linear is now closed condition, but we will think it this one is open, because of if we're using a with, for example, some CNC machines or any sharing machines, when hydraulics is completely open, after your linear is will be closed. When you push for down, after linear will be open. So that time this value will be increase and decrease. So this value how we can convert in mm or inches. So we have to be use some formula. Now total bits we got from this linear, full linear when we open, that's value we will got 20,176. So we take the calculator and we can use one formula. For example, this total bits, this is 20,176 is equal with 1 feet or 100 mm or 200, which you like to be multiply or divide, whatever, that's depend on you which volume you like to be use, mm, inches, foot. For example, I think, for example, this is the 500 mm length. 500 mm length is equal with 20,176. So what we will do, 20,176 value divide by 500. So what's the answer? 40.40 bits equal with your 1 mm. So this answer we will store. We will what we will do, stop the status and go to here and use the division command. Where is the division command? Yeah, this is the div. This is the division command. MW10, we will divide with how much answer we got. This one 40.352. Lump sum 40 we will choose with by 40 and click enter, and this we will take it in next data register. For example, MW20 we will take, and our when we increase and decrease this linear, after our total length will be shown at the MW20. And if you like to sum any, one second, I0 dot 0, for example, any you can put. And after this one MW20 also you can compare with some any relay, same as Control C, Control V, and here we will use the compare section. Go to the compare section. Yeah, here compare section you can go, and you can use the equal or greater than, simple MW20, MW30, and output one we will be generate Q0.0, for example, and this program we will write to the PLC, and let's check. Click on OK and make the status on. And now as per you can see, here is the 15 value. Example, this is our 15 mm. Here we have to be decide how much bits after mm you like to be start and stop the relay. For example, I put it here 120,176 we write, right? This is value now is okay. Then this we decide for 20,176 is equal with our 500 mm. So when we got this already shown in calculator, this 40 point, this one bits are equal with our this 20,176 500 mm. Now our linear is completely close at the 504 bits, and this is your Q0.0 is on because of we decided here for 150 mm at like to be open close. So we will move our linear also can we will be shown camera. We will open our linear, and after you can see this will be 200, 190, 170, 160, 140. See, as it's equal or greater than 150, our Q0.0 needs to be on and off. And see, this is now 150 when will be completed, after Q0.0 will be on. And as we move the value at, it will be goes at the full value of your 500 mm. This gap will be shown. So hope guys you will be understand about this analog value, how we can use in PLC S7-200. But remind this one BW0, this is a data register, but this is the AQW0 is the analog output data register, and this is MW10, this is the not sorry, AIW0 is the analog input data register in Siemens S7-200 PLC. Hope guys you will be understand. If not understand anything, you can send me the message in comment section. I will give you feedback as soon as possible. So thanks for watching. Allah Hafiz.